Hey, what's good, math junkies, and welcome to the Incredible Academics YouTube channel. You all are welcome. So today, we are basically going to be putting everything together. So what's going to be happening is that I'm kind of like going to be doing everything, sort of like taking you guys through the entire process of plotting a cubic function. And this is the function that we're going to be looking at, right? And we've already dealt with q of x before, if you guys still remember. So q of x is equals to that, and obviously you guys know that we've got two types of what? We've got two types of functions, right? Depending on the a, right? So if a is greater than 0, then you would have a function like this, right? And if a is less than 0, you would have a function like this, right? This. And the a, we're talking about what? The coefficient of x cubed. All right. So by looking at this, you can see that obviously we would have this type of cubic function. All right. So now the first thing that we're going to do, obviously, we're going to try and find the intercepts. Okay. Once we're done with the intercepts, then we'll go right ahead and find the turning points. Okay. That's like really the main things that we need: the x-intercept and the turning points. Okay, and I hope you guys still remember how to find the turning points, right? The gradient, right, is 0 there, and you guys know what the gradient is. But anyway, let's get started, right? Let's get started. So what I'm gonna do is I'm gonna start off by finding the intercept. So x-intercepts, q of x must be 0, right? Q of x must be 0 to find the x-intercepts. So meaning that the entire expression over there must be 0. So minus x cubed plus 3x, right? Plus 3x and plus 2 must be 0, but obviously we need to kind of like rewrite this whole thing: minus x cubed plus 0x squared, so that you guys can see that, hey, the expert term is actually there, just that the coefficient is 0. Okay, so you can immediately see that, okay, a is equal to -1, b is equal to 0. Well, I don't care about the c and the d, right? So I'm not going to pay much attention to that. So, but anyway, yeah. But obviously we need the root now, okay? Meaning that we need to do some guesswork and see if we can't find the root, okay? Right, so let the games begin. Let's see. So minus, we're going to start with what? I don't know. Let's just start with 1 and -1. Then we'll just keep on, guessing. All right. Plus 3, 1 squared. So that's supposed to be cubed over there. Right. And then plus 2. This is not working. Let's say -1. -1, not working as well. -2, -2, not working as well. Plus 2, giving us a 6, and then 3. Just gotta keep on trying. 3 not working. -3, not working. I hope we're not gonna be caught up in the same situation we were last time, right? And then 4 still not working. So I mean, chances are that this is another trick that you can actually use. Number 4, then you substitute all your vectors. So we've got -1, we've got 0, we've got 0, we've got 3, we've got 2, right? So x1 is equal to 2, right? So I'm just wondering what happened. I'm wondering what happened. So let's go back, because this equation actually has roots. Did you guys see how I checked if the roots are there? Mode number 5 and then number 4, right? And then you enter your A, B, C, and D so that you can check if this does have roots, you know, unlike just going on and on and on without actually knowing that this has got roots or not. But anyway, let's try it again. Minus, and then let's put -1 and see cube, because we did try -1. Hey, we did try -1, -1, or maybe I put the squared, so that's why I had issues. Okay, so x equals to -1 does work. Okay, it does work. So meaning that g of -1 is equal to 0, which implies that x equals to -1 is a root. When we say it's a root, we simply mean that we are able to actually, you know, get 0 when we substitute that x value, right? So now that we're done with that, we know that, okay, x plus 1 is a factor. Okay, meaning that we can immediately say, okay, q of x is going to be this bracket, the first factor, multiplied by something within the second bracket. Okay, so we just need to figure that out. So okay, what do we need to multiply x with to get minus x cubed? Minus x squared. And then what do we need to multiply 1 with to get positive 2? Positive 2. And then the middle term is just going to be plus kx. Okay, so now let's figure out what the k is. So k is given by what? Remember, this is also our p. K is given by apples and bananas, meaning that that's given by, we know the a by that equation is -1, the p is also -1, the b is actually 0, right? The b is actually 0, so our answer is just going to be 1. Okay, so q of x is equal to this. But there's something that I've actually noticed that could actually come in handy. X squared plus x plus 2. My learners actually know that I'm not that much of a big fan of factorizing and stuff, because not because I can't factorize, but because my learners really struggle with factorization, and I hate it when they lose marks because they just made, you know, one mistake, you know, like a minor mistake with the signs and all that. So that's why I always, you know, sort of like advocate for the usage of what, the quadratic, you know, formula. All right, so once you're at this point, my darling, you're ready to go. All you gotta do is say, okay, x plus 1 is equal to 0, or minus x squared plus x plus 2 is equal to what? 0. Okay, and then, you know, okay, on this side you're simply going to say, okay, x is equal to -1, or then on the other side, instead of you factorizing and making mistakes with signs, rather use a quadratic formula. We know that x is equal to minus b plus minus the square root of b squared minus 4ac all over 2 to a. Okay, so let's do the substitution. I mean, this is already in standard form, so we need not panic. Right, so let's do the substitution. So minus b is 1 plus minus the square root of 1 squared minus 4 ac. So a is negative 1, c is 2, divided by what? 2 times the a, which is negative 1. So let's punch everything into the calculator. Minus 1 plus square root of 1 plus 8 to negative 1. Don't copy what I'm doing. When you're actually substituting, substitute exactly as it is, because I mean I'm already doing my own calculations in my head. So it's minus 1 or what? Let's see the other root. Or 2, as you guys can see. So we've got how many roots? We've got 3 roots now. So we had the x minus 1 there, x minus 1 again, x is equals to 2 this time around. Right? X equals to negative 1 again, and then x equals 2. So we've got 3 roots now. Remember, whenever you've got identical roots, then you know that you are dealing with what? So I'm just trying to copy this quickly. So q of x is equals to minus x to the 3 plus 3x plus 2. So whenever you're dealing with so the first root, x is equals to negative 1, that's like it's appearing twice, and then x is equals to 2. So I'll still say whenever you've got 2 identical roots, what that actually implies is that you have your function, just kissing the x-axis. In other words, you're going to have a situation like this. So it's either, let's say this is the x-axis, so your function is going to be like this, right? Your function is going to be like this, depending on whether a is positive or negative. So like this, right? Yes. Or maybe it's like this. I mean, you just gotta know that one of the branches, one of the turning points is going to be right on the x-axis. Okay, so sometimes you might have a situation like this, right? Yes, situation like that. Or you might have a situation like this. You might have a situation like this. Right? Yes. One of the branches is definitely going to be, kissing the x-axis. Do you understand? For as long as you've got 2 roots that are equal. All right? But if all 3 roots are equal, this is going to be the situation. You're probably going to have a function like this. If you guys check the cubic function, it looks something like this. I mean, the standard cubic function y is equals to x cubed. It looks something like this. So yes, you can see that all the 3 roots are equal. The roots of this cubic function, that's x is equals to 0, and they're all here, right? They're all here by the x and y axis where they intersect. But anyway, we've got the roots now. So what we are going to focus on is finding what? Finding the the turning points. All right. Yes. So So to find the turning points, you guys already know that by the turning points, m is equal to 0. Okay? But what is m? M is the first derivative, q prime of x. Okay? So meaning that let's find the derivative of q of x. So minus 3x squared plus 3. Simple, isn't it? Yes, we're lucky because the x squared term is missing. So I mean, our x values, you know, are easy to find for the derivative. So q of x equals to that. So minus 3x squared, and this is the derivative, by the way, plus 3 is equal to 0. So now we take this to the other side. Minus 3x squared is equal to what? Minus 3. Then x squared is equal to 1. So x is equal to plus minus what? 1. So those are the turning points. Now if these are the turning points, these are the x coordinates. I mean x, yeah, the x values of the turning points. Okay, now we need the y values because I mean coordinates always have the x and y values. So we go back to q of x and sub these x values. You're not going back to q prime of x, because if you go back to q prime of x, these x values are simply going to make q prime of x to be 0. Alright, so we go back to q of x, then which is the original function. So then we substitute 1, and then we also substitute what? Minus 1. Okay, so q of 1, that's minus 1 cubed plus 3, 1 plus 2. And q of negative 1 minus 1 cubed plus 3 minus 1 plus 2. Alright, so we can either use a calculator or figure it out. So here 3 plus 2, that's 5, and then here we're going to have minus 1, so the answer is going to be 4. So basically the first turning point is at 1 is to 4, right? And then here we're going to have minus 3 plus 2, that's negative 1. Here we're going to have positive 1. So minus 1 plus 1, that's 0. But remember, we did say that one of the turning points is exactly going to be on the x-axis, which makes sense because the corresponding y value is 0. Right? Any coordinate that is on the x-axis, the corresponding y value is going to be 0. So therefore, if with minus 1 is to 0, and this minus 1, remember, it's actually one of our it's actually the two x-intercepts that are exactly identical, right? So we've got the 2. Obviously we still need to find the y-intercept. Okay, y-intercept. So to find y-intercept, you know x needs to be 0, so we substitute 0 in place of x. So minus 0 cubed plus 3 is 0 plus 2, which gives us 2. So y-intercept is going to be at what? 0 is to 2. So it's all systems go. Now what we're going to do is we're going to say, all right, now we know that q of x looks like this, right? Q of x looks like this. This is where it becomes very important to kind of like look at the figures that you got and think about how your graph is going to be looking like. All right, but you can see that the coefficient of x cubed is actually negative, so we know that the first branch is going to be going up, it's going to be going down, and then the other branch is going to be facing down. So but you guys will see what I'm talking about. So let me just do this. Remember, we've got turning points at minus 1 and 0. We also got turning points at 1 and 4. Right, so yeah, we're going to have a situation like this. Remember what I said, that the function is going to be kissing the x-axis where the roots are equal. Remember, by x is equal to -1, our roots are equal, so that's where it's going to be kissing the x-axis. So there we go. Right, so here it's -1 is to 0. So this time around, the x-intercepts kind of like coincide with what the what do you call that, the turning point. Yeah, so here we know it's the y-intercept, so 0 is to 2. Okay, so the turning point here, 1 is to 4, the other turning point, and then the x coordinate here, remember we found 2 is to 0. All right, so everything has been plotted now, but remember there's what we call the point of inflection. All right, the point of inflection. So I was still saying, when this is negative, the first branch, because remember a cubic function is like 2 quadratic function. Can you see there's the first quadratic function here, there's another quadratic function there that's facing down, here it's facing up. So when the coefficient of x cubed is negative, the first branch is facing up, but the second branch is facing down. Right, so that's how I kind of like crammed this whole thing. So there's something that I haven't taught you guys, which is the points of inflection, right, where the graph kind of like, you know, changes concavity. In other words, the second derivative, we found our first derivative to be what? Minus 3x squared plus 3. This was our first derivative. So our second derivative, cube double prime of x, is equal to minus 6x. So we're just deriving this again. So q of x is equal to this, all right? Therefore q double prime of x is equal to that. So now that we've done this, this is what we call the second derivative. Right? So now the second derivative enables us to sort of like find the x value whereby the concavity changes. Do you understand? So now you have to take the second derivative the same way we set the first derivative equal to 0. We're also going to set the second derivative equal to 0. So q double prime of x must be equal to 0. So this is going to enable us to find the point of inflection. Right, this is where concavity changes, right? So when we talk about concavity, we just simply referring to the fact that it's facing up or facing down. So when it's concave up, it's like this. When it's concave down, it's like this. They'll ask you, okay, which portions of the graph is it, you know, concave up? Also, where's the graph concave down? So on and so forth. So q double prime of x is equal to 0, meaning that minus 6x is equal to 0, and x is equal to 0. So that's where the function changes concavity, and this actually coincides with the y-intercept. So because if you were to find the corresponding y value there, right, q of 0, you'd find 2. Therefore 0 is to 2 corresponds, coincides with what? With our y-intercept. So this is where our graph changes concavity. So meaning that from this point up to positive infinity, our graph is concave down. But from this point up to negative infinity, our graph is concave up. And when it's concave up, that means it's facing up, literally, right? And they're also going to ask you, okay, where is the gradient of the tangent? Positive. You need to understand that whenever the graph is sloping up, right? Whenever the graph is sloping up, which is between -1, because the slope is determined like from the left to the right. So from the left to the right is a graph, going up or down. So you can see that if you were to draw a tangent here, right? If you were to draw a tangent here, it would be sloping down. In other words, it would have a negative gradient. And a negative gradient simply means that the first derivative is negative, to understand, because the first derivative is essentially our gradient. But if you were to draw a tangent somewhere here in between -1 and 1, you'd realize that the slope is positive. In other words, it's upward sloping. But if you were to draw another tangent this side, it would be decreasing. In other words, the slope would be negative. So it's just one of those things that you need to think about. But anyway, we're done with plotting the function, and I hope you guys enjoyed the video, and shout out. Don't forget to like don't forget to like, subscribe, and share with your people. Otherwise, shout out.